putting that red curve in context of the last 10,000 years, this is what it looks like. Now remember, all of civilization has evolved to cope with the stability that this last 10,000 years has provided us. Indeed, some people would say that's the reason that civilization happened when it did, because you could start predicting when the rains were going to fall. You could predict how much rain you were going to get. You could predict where the sea levels were going to be. You could predict how high the floods would rise. But we're going to go out of that. We're leaving that behind. And it's the extremes that matter. So that was just the average temperature. But what we need to understand is that's the climate. But what happens on a daily basis is weather. And so this plot here shows you how the distribution of extreme temperatures will change as a result of our warming planet. So actually, this shows you the changes that have already taken place. So the way to understand this is that this is the temperature of extremes that you'd expect in a summer in the northern hemisphere in the base period, which is 1950 to 1980. And basically, a third of the time, you'd expect temperatures to be about average. That's the white area. A third of the time, you'd expect the temperatures to be below average, so that's the blue. And a third of the time, you'd expect them to be above average, and that's the red. So I'm going to play this, and you can see how this distribution has shifted over time. So this is what it looked like in the 1950s and 60s. This is what it's 70s through 80s, 80s through 90s, and this is going into the 2000s. Okay? So what that means is that these really hot extreme temperatures that we never used to see happen are now happening. And the analysis concluded that this hot extreme, which covered much less than 1% of the Earth's surface, now typically covers 10% of Earth's land area. And this is only with 1 degree of warming, okay?